Welcome everyone. My name's Lynn Olson. I'm a General Manager Geosciences for Snowden and Product Manager for our Supervisor Geostatistical software. Today I'm going to give you a demonstration of some of the latest features of Supervisor to show you how much quicker and easier they are than running this sort of processes in a standard mine planning package. Specifically, I'm going to be focusing on our Kriging Neighbourhood Analysis KNA tool and our latest model validation toolkit. Now the data set I'm going to demonstrate with today is a gold data set. It's got multiple lenses, and the main domain is domain 1 here. You can see it's trending off to the northeast, dipping off towards the east there. I've already run a variogram on this, so I'll just give you a brief overview of what that looks like. So it's a very positively skewed data set, as you can see from the histogram. If we look at domain 1 there, it's got a mean grade of 1.86, a CV up around 1.9. So I've run normal scores variograms because of the skewness of the data set. If we have a look at the fans to start with, you can see here in the 3D viewer, the strike of the mineralization is north-south or just off north-south. You can see that in the fans. And the dip of the mineralization is around 50 degrees to the east. That's the magenta line showing up in the fans here. This is the variograms I've modelled. As I said, they're normal scores variograms. We've got a nugget of 14% and ranges around 20 to 25 metres. Now, the KNA process I'm going to go through first is very reliant on the variogram. So we have to model our variogram first, and then we can insert the KNA below the continuity models. So if we come to continuity models and right-hand click, we can add KNA. The first thing it's going to do is look at block size. So what it's going to do is it's going to set a centroid in the middle of your data, and it's going to run a series of estimates into a single block and change the block size with every estimate. We're then going to calculate the Kriging efficiency and the slope of regression and graph those results so that we can pick the block size that gives us the optimal results. On the right-hand side here, we can fill in a table of what our block sizes we want to look at. Now the data set here is on a grid of around 12.5 metres east-west by 20 metres north-south. So I'm going to look at a couple of different levels of anisotropy on these blocks. So I'm looking at a 1-to-1 anisotropy plus a 1-to-2 just to see what the impact is. And I'm going to look at two different elevation sizes. Now I can take a copy, I can use Control-C and then Control-V and drop a copy of that down the bottom and just change the elevation. So I'll look at a 2 metre and a 4 metre. On the bottom left in your library there are some defaults. So there's something there called Visor Library, and this is the control defaults for the KNA. So there's one here where you can set your block sizes. So if you're always testing similar sets of block sizes, you can set them up in there and they will automatically come up in your table. Now the next thing to do is look at the parameters that we're using for our estimates. The block centroid is simply located based on the centroid of your data, but once we've updated this so it knows where it is, we can go and adjust that in the 3D viewer. The search, orientation and ranges are drawn from the variogram. You can overwrite those by unticking the box and entering your own values. For the initial pass we use lots of samples, so it's allowed to use up to 200 samples so that we're not limiting it by the data, and we're just using a standard 3x3 by 3 discretization for the first round of tests. So you can edit those as you like. So if I update the graph, you can see what you're getting here in red on the left-hand side, and the red triangles is Kriging efficiency up to 100% maximum. The red dotted line at 80% is what we'd consider ideal in a grade control scenario. On the right in blue and the blue dots is slope of regression, and we consider above 0.9 pretty good for slope of regression. And we've got our different block size scenarios across the bottom here. Now the first thing we want to check is where is this block centroid that we've run the estimates in, and is it appropriate? So if you go and look in your 3D viewer, you can now see the location of your blocks. And you can see here that we're right on the base of the domain, so it's probably not ideal. There's an extra tab in your 3D viewer on the right now called K&A, and this is the location. So you can type your location in manually, or we can adjust the centroid by dragging these bars around. So if we locate that more central to the lens, and then we can come back to our K&A tab and update it. Now typically I will run this around 3 times as a minimum, so I'm going to run one test in the area where my dominant drill spacing is. Then I'm going to look at the sensitivity to what happens if I go to a wider spaced area or a closer spaced area if I have one. It's very easy to do a sensitivity on this. I'll show you once we've run the first one. We can simply copy and paste it, move the location and update it. Now when we interpret these results, we've got to take practicality into account as well as what the statistics show us. So what we're looking for is which results give us something reasonable. The first thing I'll do is compare the 2 metre to the 4 metre, and you can see there's not a lot of difference. The 4 metre is giving slightly better kriging efficiencies, but there's not a big difference in it. So here we're getting 0.34 for the 10 by 10 versus 0.38. So there's a slight improvement going to a 4 metre block, and 5 by 5 and 5 by 10 seem to be giving the best results, but 10 by 10 is not too bad either. So I'll say 5 by 10, that makes more sense with the anisotropy of our drilling as well. If there is a series of block sizes that all give you similar results or all give you good results, then you can pick the one that makes the most practical sense for mining. Now once we've selected the block size that we're interested in, we can come back to our Blocks tab and we can click Refine Samples, which will put the next level in, or we can double click on the scenario we've selected. If you want to test 2 different block sizes, you can double click on another one and it will put 2 graphs in at the next level. So this level of graphs is now going to look at the amount of sample data we're using for estimation. So we are going to set our block size at 5 by 10 by 4, and we're going to run a series of estimates varying the number of sample data that we're using. So I'm going to look from 1 sample up to 60 at steps of 1. And what we're looking for here is how many samples do we need to get a decent estimate, and that gives us an idea of what our minimum number of samples should be. The second thing we look at is at what point do we stop getting much improvement, and we can use that as a guide to our maximum number of samples. You still need to take the practical steps into account, such as how much data is inside your search, how many drill holes are you going to get inside a search, things like that as well. So you can see here we've got a steep drop off at the bottom here, and then when we reach around 8 samples it starts to flatten out and we start to get something flatter. And zoom in a bit on this. There's not much improvement out past around sort of 24 samples. So we could use that as a guide to picking our minimum and maximum. If you want to change these, you can click on one to untick it and click back on another one to select it. Now there's a second graph here that's also quite useful for looking at sample numbers, and that's the negative weights. So down the bottom here, there's a negative weights tab. Now what this does is it shows you in red on the left-hand side the sum of the negative weights, and in blue on the right-hand side the number of negative weights. So you can see here we're only getting 1 negative weight and it's quite small. But once we go past 24 samples, we start to get more and more negative weights. So you typically find if you use too much data, you start to getting screening effects and issues, and you start to get negative weights in your estimates. So we can also use this to help us pick that maximum number of samples. So 24 seems quite reasonable for this particular data set. These 2 graphs are linked, so if I change my selection on this graph, it will also change it on the kriging efficiency and slope graph as well. Once we've selected the number of samples we want to use, the next step is to look at your search ellipse size. So again, you can click on the right-hand side on Refine, or you can double-click on one of your selections. Now with the search, what it does on the table over on the right, gives you 5 options. The middle one is your variogram range, and then it gives you 2 smaller and 2 higher based on ratios. Now in your visor library, back where we set our block size defaults, there's also ratio defaults, so you can change those to suit. Or we can come in here and set them ourselves. So if we set some that are quite extreme so that we get a really good feel for what's going on, we'll put some really big ones in as well and see what happens. Now what this is showing us is there's not much change once you get out to 20 by 20 by 10. Now remember, this data is spaced on a 12 by 25 metre spacing, so we're probably getting sufficient samples in there. It's using the minimum and maximum number of samples that we selected previously. What we might find is that once we reach this stage, we're already getting 24 samples. Therefore, there is no change as we expand our search. If you want to see the impact of expanding the search, what we can do is increase this maximum. So let's increase that up to 100 and update. Now you can see a different set of results, and there's not much change, but there is a slight difference between some of those. But what will now happen is, if we look at the negative weights, we're getting negative weights occurring in some of those. So I'll put that back to 24 and update it again. Now in the next version of Supervisor, when we release 8.4 in January, there'll also be the option in the search table to put a key field. So you'll be able to specify the number of composites that are allowed per drill hole. So if you're using a software package that allows you to use a key field, you'll also be able to look at the impact of that on these statistics. Now the last level that we're going to do is to look at discretization. So we can select a search that we're interested in, again double click or come over here and refine discretization. The discretization defaults, again, you can set in your library. You can test different anisotropies and different discretizations. So you can see here there's not much difference. The kriging efficiency gets better when you get to 3 by 3 by 2. It's 18 discretization points, so that makes sense. We normally say you should have 20 to 30 discretization points. So there's a slight increase in kriging efficiency going up to 5 by 5 by 3, but not much. If you're in something that is very narrow vein, or you've got a very narrow cell size in one direction and quite high anisotropy, then you can find that the anisotropy of your discretization might have an impact. So it is worth having a look at it. There's a little tick button here for Show Summary, and what that'll do is just give us a summary of all the results we've selected. So that's our estimation parameters that we've selected based on this location and this variogram. Now the next step is to look at the sensitivity to location. So I'm going to come here to the K&A tab and take a copy of it. So Control C, come back to my continuity models, and Control V to drop a second copy in. Now I need to update it so it can locate itself. Once it's updated, we can go to our 3D viewer and we can move it. So let's go down, let's go up this northern end here. Put something right in the middle where we've got our closest space data. Remember, you can always adjust this manually by typing a centroid in as well. So we'll update that again. Now what we want to know here is, would we pick the same result? Now again, there's not a big difference between 2 and 4 meters, although 2 is actually giving a slightly better result. And 10 by 10 is actually giving a better result. Actually 4 meters is still slightly better than 2 meters. A 10 by 10 by 4 is actually giving a better result than 5 by 10 by 4. So you might like to test this in a couple of locations and then work out which one makes the most sense to use. I'll typically base my final result on whatever my dominant drill spacing is, but taking into account the risk in different areas that have wider or closer spaced data. We can also go and look at the number of samples and see, would we still pick the same amount? So we'd set 8 to about 24. We're certainly still seeing the start of the flattening out at around 8, so that makes sense. We're not getting negative weights in this area out until about 60 samples. So I'd probably be happy using a similar number of samples. You can see once you get past 24, there's really not much improvement in the results. Now, so far we've only looked at domain 1, so the other thing we need to do is test whether we're happy with these parameters for other domains, whether we need to change the number of samples, and whether we're happy with the block size in other domains. Now, I haven't set a variogram up for the other domains yet, but what we'll do is we'll copy this variogram down to domain 2 and have a look at it. Now, just to show you, domain 1 is our main domain. Domain 2 here is in the same orientation. It's got less data in it. So let's have a look at the impact of having less data. So I'll come to the top level of my variograms in my KNA. I'll Control C to take a copy. I'll Control V and drop that under domain 2 and then update. Now, if we just have a quick look at the variograms, you can see they're pretty nasty. There's not a lot of data, but we're probably ballpark in the right position. Maybe the ranges are slightly smaller. But we're only working here with 175 points, but it's got a fairly similar distribution to domain 1. Now, our location is not going to be appropriate for this domain, so we're going to have to move it. So I'll just delete that second one we put in there. Now let's go and have a look at our viewer. So there's no data where we're sitting at the moment, so that's why we're not getting any results. So let's drop that down into the middle of this domain and update. Now, we'd selected 5 by 10 by 4, and that's still giving us the best results. So that's good. That shows us that this block size is appropriate even for domains that have got smaller data sets. A number of samples, 6 to 8 seems to be where we're starting to flatten out, and again not much improvement out after around 24. So we'll probably select similar parameters for domain 2. Now, in fact, in this particular deposit, these are lenses that are very similar geologically and statistically. So normally we would actually combine all of these for variography anyway and use similar parameters for all of them. So that's the Kriging neighbourhood analysis process, and you can see how quick and easy that is and how quick and easy it is to do sensitivities. Now, the next of the new features in Supervisor is the Model Validation Toolkit, which we've just released stage 2 of. And once I've gone through this, I'll talk about what's coming in stage 3. In order to validate our model, we need to load it first. So when you add data, there's now an Add Block Data option. You can load directly from some software packages. Be aware, if you try and load a data mine file that is too big, it won't let you. You need to load it as a CSV file. I always recommend, to make things quicker, to copy out just your mineralized domains that you want to validate from your model. So don't try and load all the waste in. So I'm going to load a CSV file that I've got here that has estimates for all 7 of the domains that I've got in my data. Now, there's a slight difference when you load a block model. It needs to know the size of the blocks so that it can deal with any subcelling. If you don't have subcelling and your blocks are all a uniform size, then you can set a default when you run the model validation. But if you have subcelling, then you need to set these 3 fields here: X increment, Y increment, and Z increment. So there's a new mapping type in there for those. that says that that is the block dimensions. There is also a mapping type called density, so if you have a density estimated into your model, you can load that as well to get proper tonnage weighting. If you don't have density, again, you can set a default when you do the model validation. When you load your model to validate it against your data, one thing that Supervisor does require is that the column name for the domain field is the same. So my domain here is called domain in capitals, therefore my domain field in my data also needs to be domain in capitals. Okay? So if you're having problems and it's telling you it's not recognizing the domain, make sure that you have the same field name. The assay name doesn't have to be the same, and in fact we can compare our data against several different assays. So you could have an ordinary creed, an MIK, an inverse distance in your model and actually load all of those. The other thing we have to do is we have to make sure our grouping is the same as for our data. So our data is loaded here with assay over domain, so assay's at the top, then domain. So we need to come over to our grouping here and also set that to assay over domain and load the data. So you can see here I have 7 unique values in my domain field. If we go and have a look down here, I've got AU OK with 7 domains. Now it doesn't automatically insert graphs the way the data does. You can add a graph, so I can add a histogram under domain 1, and there's nothing to stop me coming up and using my control key, put them both into log scale, I can overlay them. Now the problem with what I'm doing there is that it's not tonnage weighting that estimate, okay? That is just straight point data, the way it's dealing with that graph. When we do the model validation, everything is properly tonnage weighted. If you do want to play around with adding things under your model, then what you can do is when you load it, load a field called tons, calculate tons in your model, and then you could use tons as a weight field. So you map it to a weight, and then for your assay you can come over here to weight column and actually weight it by the tonnage. That way all your graphs will also be tonnage weighted. You don't have to worry about that for the model validation because it does it all automatically. Now the check to make sure that we can validate this properly is that this domain level filter is the same as the domain level filter at the assay level. So when you look here it says domain equals 1. If I come up to my data it also says domain equals 1. You can add additional fields, so I could put a filter on my model and filter out, say, search volume is 1 or 2, or classification is measured and indicated only. So you can do that, but the top level filter line has to be the same. You can add additional filters after that. So what we do is we come to our domain and we add a model validation. You automatically get 3 trend plots, so X, Y, and Z, and you get a histogram, a log probability plot, and a QQ plot, and we also get some statistical tabulations comparing the statistics. Now the first thing we've got to do is tell it which models to compare the data to. So over here it comes up with this block data tab and you've got 3 data options. So we can come in and select our model, we can select the assay field that we want to compare it to, and then we can also put defaults. So I've loaded the X, Y, and Z increment fields. I haven't loaded density, so I could put a default density in there. Let's call it 2.7. If you want to have a default for your block size as well, then you can load that in here. You have the option to load up to 3 models. This can be 3 fields from the same model. For example, if you've run 3 different methods, or they can be 3 different models. So you might have several iterations with different parameters that you've run, You might have a grade control model and a resource model that you want to load in here, or you might like to load the old resource model versus the updated resource model and compare it to the data to see where the differences are. So if we update that, I'll take you through each of these. So the first thing we get is our trend plots. You get quite a comprehensive legend up here which you can rescale. So it shows you exactly what you're comparing and any filters that are applied. Now keep in mind it will only give you filters for the level above where you are, so any filters that are applied at the domain 1 level. It's not going to show me any filters applied at the AU level. So if you've put a grade filter or something at the AU level, you won't see that in the legend. If you go to the slicing tab, so this is our easting orientation. The granularity defaults to 5, but you can change that. The width is based on the block size, and the start and the end are based on the model, but you can overwrite all of those. Now you have the option to come up here to width and change it manually, or you can come down to the slice bar and click and drag. So it works just like the lag bar does in your variograms. So here I've got my naive mean grade in red and I've got my model in black, and I've got a bar chart at the back which is on the right hand side scale here, which is the number of samples, so that you can see the support sitting in behind it. If you've added a decluster to your data, you also get the option to show the declustered mean grade. So up here I've put a decluster in at 25 by 25 by 1, and that means on my trend plots I can also put the declustered value on. If you don't like the color scheme, you can click into here and change the color to anything you like. The colors will be carried through. All of the graphs will show the same colors for each feature. The other thing we can add is a top cut. So if I want to top cut this at say 10, I'll have to recalculate so it can calculate that. I can now show my naive and my declustered top cut as well. So it's very flexible. As with all of our graphs, you can rescale things by clicking and dragging, or you can go to the X and Y tabs and overwrite and actually type the values in there. We've got a northern graph which is the same, and an elevation graph. Now, in addition to the trend plots which we released in version 8.2, we also now have statistical comparisons built into this. The first one is the histograms. So with the histograms, this is a gold data set, so let's go to the histogram tab and turn it into log scale. You can look at the maximum grades very easily to make sure that your model is lower than your data, and you can look to make sure that the smoothing is appropriate. Now I ran one of these on a model not that long ago, and the maximum data in the model was higher than what the top cut maximum should have been in the data. So we knew we had a problem. In fact, the top cuts weren't getting applied correctly. So it's a nice quick visual validation that we are doing the correct thing. If you have a boundary in your model that is based on grade and you need to validate that boundary, it's a good idea to run this with combined domains. So say domain 1 and 2, I'd put a hard boundary there. It was 2 different grade ranges, but I'm not sure whether it should be a hard boundary. Looking at the histograms is a great validation tool for that, because what you'll find is if it is a hard boundary that you've put in there, you're probably going to end up with a double hump on your histogram for your model. And if you're not seeing that on your data, then it probably should be a soft boundary. So you can make sure you're reproducing the shapes properly in your data. You can also see the mean grades here as these 2 indicator lines. So they'll show you visually whether there's a bias between your model and your data. The next graph we see is the log probability plot. So this one here, we've got our model, our estimate, and we've got our data, our naive and our declustered. And we can see the smoothing again, we can see the minimums and maximums and make sure it looks reasonable, and we can see the mean grades as these indicator lines. In version 8.4 we'll be bringing out a theoretical global change of support, and we'll also be plotting that on here, so you'll be able to see theoretically where we think the model should be. The third graph is a QQ plot. Excuse me. Again, this shows the mean grades. Oh, excuse me. Apologies for that, I just got a bit of a cough. This also shows the mean grades for the two data sets in the model as a QQ plot. Again, when we get the theoretical global change support, we will add that into this graph. Now the last thing we get here in our model validation is a statistical comparison table. I do need to click into that and update it. This here you can see your naive sample data, your declustered, your block model. If you have more than one block model loaded, you will see multiple of those. We then see the comparison between the block model and each of the data sets that we've got selected. So you can see here that the declustered data to the block model is within 1.6% of the mean grade, which is pretty good. We can check our variances to make sure that the variance is decreasing as expected. We can look at our minimums and maximums to make sure that they are as expected. We will be looking at adding some significance tests into here as well, so t-test style. Now with the model validation, we want to be able to very quickly and easily do that for all of our domains and all of our assays. So what we can do is we can take a copy of this, Control-C, and we can Control-V that down into domain 2. That will automatically update the domain, so we don't have to redo anything. So if I update that, I've now got all of the graphs for domain 2. Now I'll just delete that for a moment and show you an easy way to do it for all domains. So if we take a Control-C, if you use your Shift key, it will highlight anything that is grouped. If you want to check your grouping, go to Group By, and Parent is what we've grouped this by, which means everything one level above, so everything under that AU tab is grouped. So if I hold my Shift key down and click on that, I can take my finger off and you can see that they're still highlighted. I can then go Control-V, and if I do it properly, we should be able to get a copy of those under each one. There we go. So we've got a copy under each domain. We can then update the entire project, and we can update all of those model validation graphs at once. So it's very quick and easy to do it on multiple domains. Now you will have to set it up once for each assay, because you need to select the assays that you're comparing to. Once you've set that assay up, you can then copy it through to each domain. So there's our domain 2 validation, our domain 3. You can see they all look pretty reasonable. So I think you'll agree that that is a lot quicker and easier than doing this in anything else that exists at the moment. It's the first of its kind, and it really is a massive time saver. Now in version 8.4, which will be coming out in January, we'll be adding a theoretical global change of support. So when you add a model validation, you will also get grade tonnage curves down here. They will show you the grade tonnage curve for your resource model, for your input data, again allowing the options of declustering, and then a theoretical global change of support using the discrete Gaussian model change of support, which looks at, based on the variogram, in an ideal world, where should the grade tonnage curve sit for this particular block size. We can use that as a validation of the amount of smoothing in our model to see whether we're over smooth or not. So you'll see that on your grade tonnage curves, plus those lines will also be included on these overlaying graphs. So that's an update of where we're at. If you have any questions, there'll be a Q&A time, or if you're listening to a recording, please feel free to send us through an email. Thank you very much.